Dear participants, welcome to this session of experiments on digital electronics. In this session, we will see or rather verify the operation of logic gates. For this, the trainer kit of Luans Electronics model F07A is being used. This is a very simple demonstration unit. You have to make as such no connection. However, we can verify the voltage that is developed at the gate output if the signals are applied or when they are absent. You have actually no access to the logic ICs that are responsible for the logic functions. However, you can very easily see them on the back side of the board. You can see all these ICs, that is the integrated circuits. They are the logic ICs. Some of them serve the function of OR gate, some AND gate, some of them as NAND gate, NOT gate, likewise. Once this particular demonstration is over, we will be continuing with another session where independent ICs will be used in a more generic digital trainer platform in which we will be having access to each and every pin of the IC. We will be applying individual signals to the pins directly and we will perform the experiment thereby. This particular session is dedicated for verification of the logic operation of the gates. Through our theory session, we have already come to know that gates are something that's an arrangement of circuit in which we have got at least two inputs and invariably one output. The only exception is NOT gate. The NOT gate always do have one input and one output. Now you see, the operation of these logic gates are very simple. If you have two inputs and one output, through the two inputs, you can have four combinations of 0 and 1. These four combinations are something like this: 0 0, 0 1, 1 0 and 1 1. You can very easily find that with these two variables, there cannot be any more combination. So the basic objective of this demonstration experiment is to see what is the output of the gates, rather what is the behavior of the gates when we apply the variables in this manner in the input. Now you see, the experiment can be finished within 5 minutes just by putting the switch on or off. The LED will glow and the experiment will be over. But important is the conclusion, that why such things are happening and what if they happen. Now see, these are just the gates. that allow you to apply them for logical decisions. Let us take one simple example. समझो एक बड़ा मशीन है जिसमें एक वेरी मैसिव कटिंग ऑपरेशन चल रहा है. देयर इज अ वेरी मैसिव कटिंग ऑपरेशन एंड द ऑपरेटर हैज टू push the material to be cut inside the machine by his hands. ऐसे परिस्थिति में अगर मशीन कंटिन्यूअस चलता रहेगा और जो ऑपरेटर भाई साहब हैं, if he tries to put the material by his own hand inside the machine when it is in operation, there is always a chance of accident. तो ऐसे में हम क्या कर सकते हैं? Under such a condition, we use an arrangement called two-handed safety circuit. Two-handed safety circuit. अब ये टू-handed safety circuit में क्या होता है? दो स्विच रहते हैं. दो स्विच काफी दूर दूर में रहता है ताकि इंसान को दो हाथ फैला के वो दो स्विच को दबानी पड़े. अब जब इंसान वो दो स्विच दबाएंगे तभी वो कटिंग टूल जो है या फिर कटर जो है, ब्लेड जो है, वो ब्लेड नीचे आके कटिंग ऑपरेशन को परफॉर्म करेगा. नाउ इन दिस कंडीशन यू कैन सी द ऑपरेटर हैज बिकम कंप्लीटली सेफ. फर्स्ट ऑफ ऑल he has to remove his two hands from the switch so the cutting tool will be raised. उसके बाद he will be putting the material that is to be cut under the cutting tool. He will remove the hands from the operation bed or the cutting tool bed. Then he has to push both the switches by his hands. अब जब उसका दोनों ही हाथ स्विच दबाने में व्यस्त रहेंगे, under such a condition there is no possibility that during the cutting operation his hands will be on the operation bed or anyhow inside the cutting machine or under the cutter whatsoever. तो अभी बात क्या हो रहा है? देखो, इसमें दो स्विच है. अगर दो ही स्विच ऑफ रहेंगे अर्थात उसके ऊपर उसके हाथ दबा हुआ नहीं रहेगा, कटिंग मशीन विल नॉट ऑपरेट. अगर एक भी स्विच चालू रखा, मतलब ऑपरेटर भाई साहब ने ये सोचे कि मैं एक हाथ से स्विच चालू रखूंगा और दूसरे हाथ से मटेरियल को अंदर भेजूंगा, ये भी पॉसिबल नहीं है. ये तभी पॉसिबल है जब ये ऑपरेटर भाई साहब दोनों ही स्विच को अपने हाथ से दबाएंगे. अच्छे से ख्याल करके देखिए, दिस इज वेरी मच इक्वल टू द ऑपरेशन ऑफ एन एंड गेट. ये ऑपरेशन को एक लॉजिक ऑपरेशन हम बोलते हैं. When both of the switches are pushed, then only you will have the output. Otherwise, you cannot have the output. So such type of application can be developed with these gates that we have to think. Just by pushing the switch on and seeing that the output is high or low, it will really make no sense. Therefore, we have to think of such applications and we have to understand the essence of the operation of the gates. Now let us look at this board. The operation is very simple. There is one mains power supply and there are several switches that are at the input of these gates. We have in all 6 different gate operation that can be displayed in this board. There is OR gate, AND gate, NOT gate, NOR gate, NAND gate and XOR gate. You can see each of the gates have 2 inputs and there is one output. You can measure the output voltage And you can also see the condition of the output through an LED. There is one 5-volt supply and one ground. You can see this particular symbol signifies that if the switch is pushed on the right side, a logic high will be applied to the gate input, and if the switch is pushed to the left side, a logic 0 will be applied to the gate input. Now we are very sure about the truth tables of the gates. So let us directly get into the demonstration. Initially, what I have done, I have kept all the switches in logic low condition. These are toggle switches and they are giving TTL signals or TTL compatible signals at the input of the gates. So I will put the switch on. You can see that some of the LEDs are glowing and some are not glowing. These are the output indicators you can find. So let us now start with the operation of a NOT gate. You can well see that when the logic is 0, the output is high. You can see this LED is glowing. If I make logic 1, the output becomes low. So you can very easily understand that this is simply an opposite operation taking place when we are applying a signal at the input of the gate and we are trying to find the output at the output of the gate. The symbols are already known to you definitely through your regular theory coursework. Now let us go for AND gate. In AND gate we have seen in our theory lectures that unless both the inputs are logic high, the output will never be high. Let us try to verify that. Now you see in the initial condition both the inputs are low, logic low, so there is no output. I will make one of the switches high. You can see that the output is still low. I will make this input low and another input high. Still you can find that the output is maintaining a logic low status. Now I will make both the switches high. When both the switches are high, you can find that you have got a logic high at the output. Now let us try to go for OR gate. In an OR gate operation, we know it very clearly that when both the inputs are low, the output will be logic low. When any of the input is high, the output will be high. Because this is the significance of OR operation. This input or this input need to be high so that the output is high. You can see this is fundamentally different from the AND operation. In AND operation, you need this input and this input to be high. Now you can extend the number of inputs. The condition will remain altogether the same. If you have an AND gate with 4 inputs, which is very much possible in digital logic ICs only, or you can make combinational circuits for higher input operation, you will find that all of the inputs are needed to be high when you want a high output at the NAND gate or AND operation. Now let us go for OR operation. Both the inputs are low, so definitely the output is low as we had expected. One of the input is high and you can find the output is high. I will put this low again and I will make another input high to see. Yes, the function is altogether same. Now I will make both the inputs high. So you can see the high state is retained. Now another interesting point that we would like to see here, that what is actually the voltage at the output. This is getting high. Does that mean that it is essentially at 5 volt? Because whenever we are talking of a logic high, we call it as 5 volt. Okay, so this is a ground, and this is the ground where I have connected my voltmeter. I have kept my voltmeter at a range of 20 volt. I will put it here. Now you can see it's a logic low. Now when it's a logic low, you can find it is not 0. It is 0.13 volt. Now I will make one of the things high, and you can very easily see that it is not exactly 5 volt. It is not exactly 5 volt. It is actually 3.46 volt. Again, I will be using it in case of an AND gate. Sorry. Yeah. I'm using it in case of an AND gate. You can see when both inputs are 0, the output is exactly 0. And when it is high, the output is 4.91 volt. Here, I would like to mention one thing, that whenever in case of an NOT gate, we can see it is 0, and when it is high, it is something around 3.20 or something. Okay. Remember one thing, that whenever we are talking of a digital circuit, okay, a high, theoretically it is definitely 5 volt, but actually in a TTL circuit, any voltage which is having a value of more than 3 volt is considered to be high. More than 3 volt is considered to be high. And in case of low logic, it should be 0.8 volt. Okay, so any signal below 0.8 volt should be considered as low. Now many texts, they also write that 1.8 volt, but please consider this to be zero point 0.8 volt. That's a better approximation. Okay, now I will show you another tool which is actually called a logic probe. You can find this is a logic probe. A logic probe has got two inputs. One we have to connect at 5 volt and other at ground. So when it happens, you can see a P is being indicated. What is the meaning? You can see here that whenever some circuit is open, it will indicate O. For a low logic, it will indicate L. For a high logic, it will indicate H. And if a train of pulse is there, it will indicate P. So let us see now if this thing actually happens. So it has got a notch like this, so that you can actually connect it to the terminals of an IC. I will put it here. Now you can find it is low. I will make any of the inputs high, it becomes high. Okay, so this is a logic probe actually. I will put it in an AND gate configuration. You can find both the inputs are low, the LED is not glowing, so this is low. Both of them are high, it is H. So this is another very interesting tool, an important tool in digital electronics that helps you to find the logic conditions. Now let us get into the operation of NOR gate. NOR is something that is exactly negative to OR. Right? So we can see here, if both the inputs of OR is low, the output is low. Now here in this case, both the inputs are low, but the output is high. Now you can find if one of the input is high, the output is high. Here you can see if both the inputs are, if one of the input is high, the output is low. Let us check it for another input. You can find the output is low. Now if I make both of them high, it will keep a low status. This is exactly opposite to that of OR gate. Therefore, what we actually consider is that if we connect a NOT gate at the output of an OR gate, we will find what is happening at the output of a NOR gate. Therefore, NOR is nothing but not of the OR operation. Now let us verify this thing with the NAND gate. You can see here, in case of an AND gate, when both the inputs are low, the output is maintaining a low status. Now here in case of a NAND gate, both the inputs are low. Still, we have got a high status. Now I will make one of the inputs high for the AND gate. You can see there is no output. That is, the output is maintaining a logic low. I will make one the input high. You can see the output is maintained at high status. Now I will make both of them high, or I will check for another input. I will also do the same thing here. You can find, yes, it is maintaining. Now what I will do, I will make both the inputs high for an AND gate. Now you can see the output is transferred to a high logic. Now when both the inputs are high for this NAND gate, you can very easily find that the output is low. So this is exactly not of the AND operation. Therefore NAND is nothing but not of AND operation. Now you find this XOR operation. This is a special case of OR operation, which is known as exclusive OR. You can see here both the inputs are low, the output is low. One of the input is high, the output is high. You can see it is the same as OR operation. One of the input is high, the output is high. I will make another input high for the OR operation, and I will repeat the same operation here. It is high. Okay. Now I will make both of them low. You see both of them low. They are low. Now see the difference. I will make both the inputs high for an OR, and I will make both the inputs high for an XOR. You can find the output is low. While in case of an OR, the output is high. Now try to understand the importance of an XOR operation. You can see the output is low when both the inputs are equal. That is, this input and this input, both of them are at logic high. The output is low. Again, here both of the inputs are at logic low. So the output is low. If one of the input is high, then the output is high. So if you have some sort of logic operation where you actually want the output to be low, when both the logic inputs are at same condition, then you have to use an XOR gate. Remember, your output should be low in case of an two input logic. If the two inputs are at logic low, then only your output will be, sorry, I must say, if both of the inputs are at same logic, then only your output should be low. If such is the condition, then you have to use XOR. You can see again, both of the inputs are same, then the output is low. The input condition is different, the output is high. Again, both of the inputs are same, the output is low. This is exclusive OR operation. So this is all about the demonstration of logic gate operations. After this, in the next session, we will be actually studying the operation of the logic gates by using the ICs and applying logic signals directly to the IC pins. Thank you for now.